Make sure this works. Boom. 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 Yeah, let's go. Truth be told, 3.2b and 3.3, I've already hit. It's the unit circle stuff. And 3.2b may be more confusing than 3.3. And you can get by without even knowing anything from 3.2b. So I want to kind of go over it just to make sure that you don't have complete blank stuff on your notes, like what the heck did we do here? But I want to make sure, does that kind of make sense there? And we'll hit 3.3, and then we'll talk about what we're going to do for homework and that kind of stuff. Will kind of lead us into the next couple of lessons. But all that chapter 3 at the first part of it up until like 3.5 is basically, if you know the unit circle, you can do all that. You can do all that stuff if you know the unit circle. So that's a couple things I want to do today is make sure that you know it, make sure you understand it. And again, knowing it and memorizing it, I think, are two different things. I think you're better off knowing it than having it memorized. Although there's a fine line between those two, right? Again, do you know that the square root of 4 is 2, or do you know that the square root of 4 is 2 because you have it memorized? So I do think there's a fine line between that, but knowing that 2 times 2 is 4, kind of knowing it as opposed to memorizing it. I hope I'm making any sense whatsoever to you. Okay, so that is our plan today, is to go over those notes. First, I know it's been, it was last Wednesday, guys, so this is like, that's a spring break and plus some, since we've spoken over 3.2. Remember, we did do 3.1 also, so we have a 3.1, which was the repetition stuff. Remember that is going to be a question on your test. Okay, that last one where I think I had you guys do maybe A, B, and C, or not. I had you do A, B, and C, the whole worksheet, but there is a D and an E, or there's a couple more questions. And so those are for practice, but you're going to have some type of something that goes around and does the repetition. Okay, and so you have the periodical functions. So it goes for a certain period and it repeats. And they'll talk about the smallest time that it repeats, because it repeats every 8, but it also repeats every 4. So if it's 4 here and it's 4 here, well, that also repeats 8. So they'll want the smallest number that it repeats, if that kind of follow. Anyway, that's a big deal. So don't forget about that kind of stuff, although it has nothing really to do with the unit circle. Okay? Yep. Yep. Go ahead. She's probably there by now. You okay?
Yeah.
All right. Yep. She fall down on the way to school today. Had a boo-boo. So she took your spot, except she didn't get broke. So 3.1a or 3.2 part A or part 1. I don't know how they call it, part 1, part 2. I like to call it part A, part B, right? A lot of you guys turned it in. Some of y'all didn't. I put your little notes. We got to get stuff turned in. Don't forget. That's been a while. Most of it was multiple choice. So y'all kind of remember, most of that's multiple choice. I don't look to see if they're right or wrong. You guys, that's up to you guys to check answers. I typically have been posting answers for this stuff. Remember that I'm not necessarily, if you want to know it, don't necessarily know which one's right. Make sure you know why the other ones are wrong. I think that's just as important as learning this as knowing which ones are right. So that was there. I don't have any of those. I didn't save them. Let's see, where am I at? I got bored on 2048 real bad over break. I'm still going. Ever played that? I'm getting bored. If I can build that one up, it will go to there and go. I don't know. Anyway, got a long time. I did that instead of PD. Here, 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 backspace, backspace, 3-point notes. No, 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 no. Don't open, don't open, don't open, don't open. Worksheets. Worksheets. Unit 3 worksheets. 3.2 worksheets. Sine, cosine, tangent. 3.2 worksheet A. I'll just pull the key up. That's fine. That's what I posted. So it's red giving you the answer, right? Yo, you're kind of got the unit. I don't want to say it's a unit circle because it may not be the unit circle. In fact, bless you. God, we got wait. Bless you. These are not unit circles because the radius is a little bit longer than unit. For instance, this one was something else. Well, I don't know what it was. 7. So anyway, there's a 3, 4, 5 triangle. Know your 3, 4, 5 triangles and the 5, 12, 13 triangles. That's going to get you very far in life, especially on the ACT. They're very, very common type triangles. Because we don't want you to spend the time to do the Pythagorean theorem to find something, because we're not testing if you know how to do the Pythagorean theorem. Y'all kind of follow what I'm saying, right? So if we're not testing if you know how to do the Pythagorean theorem, we're going to do something that makes it pretty easy. Now, not to say that it's not going to be on there, but those are the common ones. So that's 3, 4, 5, and this one was not. So you had to use the radical one. Actually, you didn't have to because it was just YX. They gave you 3. There's the 5, 12, 13 triangle. So 3, 4, 5, and 5, 12, 13 are the most common. Another multiple choice, another multiple choice, another multiple choice, and another multiple choice. And then finally, you had to do some SOHCAHTOA stuff. And that's all this was SOHCAHTOA. It really had nothing to do. Again, I could have given you this worksheet, I think, at the start without having to teach you anything. Maybe, no, because it was all SOHCAHTOA. Maybe you had to understand the quadrants and that kind of stuff. And that was topic, that's topic 1. Okay, that's all topic 1. That's where I kind of wanted you guys to stop, right? Number 16. So 6 pages. Hopefully you uploaded 6 pages. Sometimes I know there's issues. Sometimes it doesn't get the last page. Just get it to, and really all I'm looking at is the last 2 pages. I'm really not even looking at the multiple choices. I mean, I don't know if you did that or not, if you circle an answer, whatever. I'm really just looking at the last 2 pages when I'm looking through these. I've done a lot better job of looking through your guys' stuff. Not just looking to see if you turn it in, but looking through it. Everybody okay? Good? So nothing big time, right? Everybody okay? So don't forget 3.1, periodic stuff. And if you remember 3.1 periodic, that really has nothing to do with this stuff that we're really doing now. We're going to tie all that in around 3.5 or 3.6. We'll tie that in together a little bit. Okay. I have updated the calendar somewhat. I stopped updating it, but so we're in January for just a little bit longer. Snow day. So here's today, 3.2b and 3.3. Homework wise, I'll explain that when we get to it. Okay, and then we got, I'm going to throw 3.4 here, probably have 3.5 here, but somewhere in there, we're going to have a quiz. So either, probably not Monday, we'll plan on Wednesday, but probably have a quiz over something. But everything kind of got shifted a day. Just kind of ACTs here for you juniors, but that doesn't affect us because we're just A days. And even if it did, it still doesn't affect us because we're 0 hours. So just kind of keep in touch with everything, right? So I need to go here, and I need to go this thing. Where's that thing at? I need this edge. I use edge instead of chrome. Is she there? Dadgummit. 3.2b notes right there. Enter. Beautiful. There you go. Let's go ahead and put 3.3 notes here. Enter. 3.3 notes. Beautiful. 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 Okay. 3, 2B. He calls it 3-2 part 2. I like to say 3-2B. Okay. And truth be told, and I was just talking with Ms. Gross about it, and she kind of thinks the same thing I do. I don't know want to say it's confusing, but I think I think you guys are past this stage. How about that? I think this muddies the water almost. So I'm just going to kind of walk through it just really quickly. Reminder, the coordinate plane is an angle in standard position when the vertex is at the origin and one ray lies on the positive x-axis. So every one of these guys, you're going to get into a big habit, I hope, of every time we're talking about this stuff is you're going to draw an xy axis and you're going to have a circle of some sort. And that circle is always going to be centered at the radius or at the origin. So some kind of a circle. Sometimes I draw a circle and sometimes I don't. Sometimes I'm just concerned about the angle more than I am the circle. But you have the standard position, and so that bad boy always starts off right there. And so from there, I'm either doing a positive angle or a negative angle. And you can name every angle infinite ways. We don't use degrees anymore. All we're using is radians. So this one could be pi over 4 radians, or it could be negative 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, negative 7 pi over 4. Okay? So you should know that that's pi over 4 or negative 7 pi over 4. Or I can go all the way around and all the way around and all the way around again, but most time we just go around one time. So it could be I say 1/4. Anytime I say 1/4, it's pi over 4. So this is pi over 4 radians, right? Remember, all the way around is 2 pi because that's the unit circle. It's the circumference of a circle. So the circumference is 2 pi r. And because it's a unit, r is 1. So all the way around is 2 pi. So that's a quarter of all the way around. 1/4, 2/4, 2/4, 1/2. 3/4, 4/4, 1. 5/4, 6/4, 7/4, 8/4, 2. And so that, I'll just count it. That's it. I memorize where they're at. I don't care. Count them. 1, 3, 5, 7. 1, 2, 3, 4, 5, 6, 7. And if it says 28/4, that's 8/4. That's 16/4. 24/4. Yeah. Or you can go this way, negative. Negative. So down is negative, up is positive. Okay, again, hopefully that's just a, oh yeah, I remember type things. But so that's what they're talking about right here. Standard position, it always starts off right there. That's standard position. It always starts there. Always starts there. Unless we're talking about a reference angle, we're always right there. And then the terminal basically is where we're going to end up. Where are you going to end up? You're going to end up in quadrant 1, you're going to end up in quadrant 2, you're going to end up in quadrant 3, quadrant 4, or are you going to end up on an axis? You might end up straight up. You might end up over here. Okay? So, standard, terminal. That's what they're going to talk about right there. We've already mentioned it because we had a dog and a duck, right? We had a boat, dog, duck. Positive, negative angles. Positive angles are counterclockwise. Up. Positive angles are up. Negative angles are down. Again, stuff I hope you already know, but we have the aha moments. There we go. Up. Uh-oh. Up. Down. If you don't want, I mean, I don't know if you guys know about a clock nowadays. It's all digital. Anyway, up and down. Figure above indicates a positive angle because its direction is rotated counterclockwise. Oh, and the only reason why I know that is because the arrow went this way. It could have easily gone this way and gone negative. Okay, beautiful. Oh, I don't want to draw. All right, beautiful. Measuring angles. So this is where they're talking about the arc length and the radius, and I think this is more cumbersome. It's talking about the arc length as opposed to this angle. And so that's the difference between a degree and a radian, right? This degree is kind of right here, but the arc length is the radian because it's 2 pi all the way around. So that's kind of where they're starting to introduce that to you, but I've already done all that. So the radian measure of an angle is in standard position is the ratio of the length of the arc of the circle of the origin created. That's more confusing than just knowing that you're just going around a certain thing, I think, to me. The circumference is given by 2 pi r. So either X all that stuff out or whatever you want. I mean, you need to know it, but I think you already do. So there's theta, that's an angle, I guess, and that's the radian. 90 degrees, pi over 2. Again, we're not going to deal with anything with degrees. In pre-cal, prior to AP pre-cal, we would spend easily a week converting radians to degrees and degrees to radians, and that would always just be part of the test. We don't have to do that here because we're not dealing anything with degrees. So kind of associating the two for you guys will help you, knowing that 90 degrees is the same thing as pi over 4 or pi over 2. But if you don't know it's 90 degrees, you're okay. If you don't know it's pi over 2, you're not okay. You got to know that that's pi over 2. Consider the angle theta, find the measure of theta in radians. You don't have to find it. It's pi over 2. Uh-oh, what am I doing? Oh, I don't want to hit that. Gosh, dang it. Sorry, dyslexia. Pi over 2. It doesn't have any symbol. There's no degree. Don't put the symbol degree. Don't put a degree symbol. It's, if you want to, you could put to the R, but it's just nothing. It's pi over 2. It's just a number. Find the measure of the angle formed by a third of the circle with radius of 3. See, that's not even, nothing. Everything's going to have a radius of 1, unless if it doesn't. And the unit circle is where he's talking about this now. So there's the unit circle. Beautiful. X squared plus y squared is z 1. Unit circle. The concept. Who cares? All right, so sketch it. This is you should be able to do this. However, I wish he would have just went ahead and pi over 6 as opposed to 1/6. Okay? Instead of saying 1/6, I wish he would have just said pi over 6. And so you should know that I'm going to have an x-axis and a y-axis. I know I say that wrong. I'm sorry. X-axis, y-axis. And 1/6 of it, I don't care. Just get close. And I don't care how far out it goes. I don't care how far out it goes. I don't care as long as it's closer than halfway. Because halfway is 1/4. That's 1/6, that's 1/4, and that's 2/6 or 1/3. 1/6, 1/4, 1/3. 1/6, 1/4, 2/3. And then that's either 3/6 or 2/4 or 1/2. There's a bunch of ways for that one. Next one's what? 2 full revolutions. I don't know how you're going to do 2 full revolutions. 1, 2. I guess. I don't know. Oh, I did clockwise. Doesn't matter if you do clockwise or counterclockwise. The important thing is where you end up. Y'all okay? Good? I'm glad you caught that, though. So I did that wrong. Clockwise. Clockwise. So it should have gone this way. So whatever. This is not that. 3/4. Again, I wish it was 3 pi over 4. You know it's 3 pi over 4 rather than 3/4. So y-axis, x-axis. It says counterclockwise, so that is important because 3/4 counterclockwise is different than 3/4 clockwise. So counterclockwise, this way, up. Counter is up. Clock is down. Clock moves this way. So that's clockwise. Counterclockwise means the opposite of a clock. So 1/4, 2/4, 3/4. The thing that might mess you up is forgetting that it's 2 all the way around. So that's 8/4. This is 4/4. 3/4 is just up 1. Talk to me. I don't care. I know. Go with what I'm doing. I don't want it confusing. That's why I'm doing what I'm doing. I hear what you're saying. Yep. It is. Because pi over 6 counterclockwise is here. Pi over 6 counterclockwise is here. Good question. Everybody, y'all hear what his question was, right? Pi over 6 counterclockwise is right here. Pi over 6. So Jonah's trying to mess me up. He's doing a good job. They're wanting to do the whole circle. I'm wanting to do the unit circle because I want you to know the unit circle. So that's kind of why that's why I said 3/4 pi as opposed to 3/4. Good. 7/8. I don't care about 7/8. Yeah, I do. That's the same. No, that doesn't reduce. Good enough. I care about the fourths. I care about the sixths. I care about the thirds. I care about the halves. And all the halves reduce from those 3. So really all I care about is the sixths and the fourths and the thirds. And the thirds I don't care about because it's really the sixth. So really it's the sixths and the fourths is all you got to worry about. Just to make sure we're all on the same page. Mark that out. The sixths, 1 6 2 6 3 6 4 6 5 6 6 6 7 6 8 6 9 6 10 11 12. There's 2 here, there's 2 here, there's 2 here, and there's 2 here, and mine look like crap because they're nowhere equidistant from all of them, but they're supposed to be equidistant. And if you go down just a little bit further, I think they've drawn it correctly. Because that's all we care about. The 1 6, the 2 6, and the 3 6, and the 4 6. Now 4 6, you got to make that 2/3. 4 6 5 6 6 6 7 8 9 6 10 11 12 6. And now when I say 12 6, guys, it's 12 pi over 6. Okay, those are the ones you got to know. You got to know those radian measures, positive and negative. Positive and negative. So 1 6 2 6 3 6. Don't be jumping around on me like this. Draw. Where'd it go? Here it is. 1 2 3 4 5 6 7 8 9 10 11 12. And then you got to know the fourths. And the fourths really are nothing to do with the 6. The fourths are here, halfway. 1/4, 2/4, 3/4. Skip all the sixths. Another thing that students mess up there on is they'll skip the axes. Don't skip the axes. 1 6 2 6 3 6. And after doing this for so long, if it's the thirds, you'll start skipping the sixth. 1/3, 2/3, 3/3, 4/3, 5/3, 6/3. Yay? I don't need that. The circle has the markings and the important angles that will be used repeatedly throughout this course. I'll say that again. The circle above has the markings at the important angles that will be used repeatedly throughout this course. The circle above has markings at important angles that will be used repeatedly above. Hopefully it's easy to you right now, like, good gosh, shut up, let's go, I got it. But I need you to get it. And that's why sometimes it doesn't hurt you to draw the stupid thing and start just counting angles. It'll make sense to you in just a more second. Okay, example 4. Okay, we've already talked about this already. You already know this, I hope. You know sine, cosine, and tangent because this is nothing more than SOHCAHTOA. It's nothing more than SOHCAHTOA. You know that sine is opposite over the hypotenuse. You know that cosine is adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. Or sine over cosine. You may not know that one, but hopefully you do. Sine over cosine is the same thing as tangent. The sine of angle is sine, tangent. Tangent is y over x, or opposite over adjacent. Opposite. So we're always doing our angle from here. We're always looking at this angle at the origin. We're never looking at this angle up here. We're never looking at that angle, always from the origin. So kind of, I know triangles you can look at. We don't ever look at the right angle. We never have looked at the right angle. We're looking at the small one or the other small one. You're always looking at the one at the origin, okay? And then this here, we talked about this day one, however many moons ago that was now. This was not last Wednesday, it was before that. This is like my dog and duck, right? The opposite and the adjacent, the 30 degree, and if you know the 30, 60, 90, or the 45, 45, 90, and if you guys remember, I told you really, there's only, you gotta have a 0, you gotta have a 1, or the square root of 1 over 2, which is tricky because that's just 1/2. Or the square root of 2 over 2, or the square root of 3 over 2. That's the only ones you got to have memorized. Only ones. Now, I say it's the only ones. That can happen infinite ways. It can happen infinite ways, but those are the only ones you got to know. You just got to know those. If it's right here, it's going to be a 0 or a 1. It's going to be a 0 or a 1. Just depends on if we're talking about sine or if we're talking about cosine. Right here, it's going to be a 0 or a 1. It only matters if we're talking about sine or cosine. Right here is going to be a 0 or a 1, but the 1's going to have to be negative because it's that way. But it's still a 0 or 1. Now you just got to start thinking positive or negative. And depends on if we're talking about sine or if we're talking about cosine. Down here can only be a 0 or a 1, but the 1 has to be negative because we're talking down there. I mean, none of that's changed. It's still the coordinate grid. So you already know that that's 0, negative 1. If I gave you a coordinate grid and I told you to plot that point and plot 0, negative 1, everybody would put that point. Just again, we're talking about sine or cosine. Square root of 2 over 2 has to happen at the force. It has to, because it's an isosceles triangle. So it will be, I don't have, that comes up in a second. That's not this one. That's the fourth one. So if it's a fourth, it's a square root of 2 over 2. It just depends on where it is. But what's nice about that one is, it doesn't matter if it's sine or cosine, it's a square root of 2 over 2. Again, just things you just got to get it in your heads. 1/4, that has to be a square root of 2 over 2. Just one of them is negative. X is negative. X is cosine. Because cosine's the one that goes left or right. Cosine is the adjacent. Cosine is the adjacent. Sine is the opposite. Sine is y. So sine is positive here, but cosine is negative here. This is the square root of 2 over 2 for sine or cosine, but they're both negative. And just something you already know that down here in quadrant 3, you know that both x and y are negative. You know that. So just go with what you know already. You may have not known that was the square root of 2 over 2, square root of 2 over 2, but now you do. And down here, square root of 2 over 2. And just one of them's positive and one of them's negative. And the x has to be positive and the y has to be negative. So the zeros and the ones and the square root of 2 over 2's, those are like the easiest ones. I think the square root of 2 over 2 is almost easier than the 0 or the 1 because this doesn't matter if it's sine or cosine. This one matters if it's sine or cosine. You got to think. Was the duck up in the air or was cosine had to go out and was the duck on the water? That's where the water and the duck comes into play, right? The duck straight up, and the duck's 1, but cosine didn't go anywhere. Dog didn't go anywhere, so cosine's 0. But if the duck's on the water, that's where cosine's 0, but cosine had to go out and get him. Cosine's 1. Or cosine had to turn around. Or we got the magic duck that's underneath the water. Oh yeah, it'll start making sense at some point. Let me keep going. Keep going. And then the last two are, I think, truthfully, the harder of all of them. It's either the square root of 1 over 2 or it's the square root of 3 over 2. Notice I didn't say square root of 1. It's actually 1 over 2, but the square root of 1 is 1. So it's the square root of 1 over 2, square root of 2 over 2, or the square root of 3 over 2. But the square root of 2 over 2 can only happen at the 45s. And then the zeros and the ones can happen only on the axes. And so these happen at the 30s or the 60s or the 6th or the 3rds. And so this is where I don't have it memorized. I just think about it. If this says it's 1/2 square root of 3 over 2, then that has to be the 60, or that has to be the 1/3 or the pi over 3. It has to be, because this is short and that's long. Because I promise you, that number right there is smaller than this number right here. How do you know that? Well, the square root of 3 is bigger than the square root of 1. The square root of 200 is a whole lot bigger than the square root of 1. So this has to be the bigger. Well, if that's the bigger, that has to mean that this is the long side and that's the short side. And if this is the long side, that has to be the bigger angle. And if that's the bigger angle, that's the 3rd or the 2/6. Short, long. If it's the short, it has to be the 1/2. If it's the long, it has to be the square root of 3 over 2. And that's where you just have to sometimes just do a little bit of thinking, and maybe you have to sketch it. Maybe you have to sketch it. It's okay to sketch it. Again, all this will make sense to you in just a second when I show you what is going to be expected from you. I don't care about example number 5. I just went through example number 5 and 6 and 7 and 8 and 9 and 10 and all of it. You already know that. The point R is a result of done. Okay? Done. So let me hit 3-3. Let me hit 3-3, which I think is more important than 3-2b. I did have a couple of you guys actually do 3-2a and 3-2b and turn it all in on your homework, because that's how easy 3-2b 3-2-2 was. You could have done that for the most part. Okay. 3-3. Focus this, and here we go. Coordinates of a point on the surface signal origin, given the point, terminal array intersects the circle. I got a unit circle, and I got a point right here, and I'm going to end up somewhere on the unit circle. It says R cosine theta and R sine theta. That's nothing more than SOHCAHTOA. Again, SOHCAHTOA is going to be, SOHCAHTOA. From topic 3-2, we know that cosine is adjacent over hypotenuse. And instead of saying adjacent and hypotenuse, they're going to say x, because your adjacent is always going to be x, and your hypotenuse is going to be r, which is the radius. So they're going to switch it just a little bit on you, but it's nothing you don't know already. X over r is the same thing as adjacent over hypotenuse. And y over r is the same thing as opposite over hypotenuse. So they're going to change the hypotenuse to r, because it's the radius of the circle. Okay, whatever. For those two sides, so easily by using algebra, I can multiply both sides by r. I don't know why I would do that, but you can. So r cosine theta is equal to x. And r sine theta is equal to y, and that's how they got this right here. Again, I think this is almost more confusing if you already know the 1/2 and the square root of 2 over 2 and the square root of 3. None of this is going to mean anything to you. It's not going to mean anything to you. The figure above shows a circle with a radius of 4. So he threw a little curveball into you, because now we're not talking about the unit circle. We're talking about a radius 4 circle. Okay, whatever. That's why we use the unit circle, because if you know the unit circle, it doesn't matter what the circle is, because everything, if it's 1, then you can just quadruple everything, or in this particular case, we'll quadruple everything. Anyway, it's got a equilateral triangle. We got to start using a little bit of geometry here. equilateral triangle. That means what? All three sides are the same. And if all three sides are the same, then all angles are the same. And if all angles are the same, they all have to be 60, because 60 times 3 is 180. And so this is a 60-degree angle, and that's a 60-degree angle, and that's a 60-degree angle. And that makes it a little confusing, because if this is 60-degree angle, then that means that this has to be 30 degrees. And if this is 30 degrees, this is 60 degrees. I thought I was done with geometry. No, you're not. Whoops, sorry. Again, I told you I know I was done with degrees, but sometimes we work better with degrees than we do in our heads. But if you know that that's 60 degrees, and that's also pi over 2 pi over 6 or 3 pi over 3. It's going to be one of these that you know. If it's not, you have to use a calculator. If it's not one that you know, you have to use a calculator. And so they're going to give you one that you know. It's either going to be a 30, it's going to be the 45, or it's going to be the 60. Again, hopefully you're bored with all this stuff. So you should know that that point right there is either the 1/2 or the square root of 3 over 2. It depends on if I'm talking about the adjacent or if I'm talking about the hypotenuse. I'm sorry, the opposite. And this is going to be the same because it's a mirror image of this over here. It's just one of them is going to be negative. And so this is the short, and this is the long. Okay with all that? Good? Yay? Except we know the hypotenuse this time is 4. So it does change it just a little bit. But I don't think it will down here because my answers are not like that, right? The figure above shows a radius of 4 along with an equilateral triangle. Which of the following gives the ports Q? Well, what do you know about Q already? X is going to have to be negative. And Y has got to be positive. So you should know that before you even come close to taking this class. And if you already know that, I guarantee it, your answer is not going to be, well, now hold on. Let me rephrase that. Got to be careful. Some students might jump right in and say D is the answer. But where is 2 pi over 3? So now we got to do it. Now you can't answer this without knowing this class. Okay? So 2 pi over 3. Well, that's the same as what? 4 pi over 6. Okay with that? 4 pi over 6. So this is 1/6, this is 2/6, this is 3/6. So that's 4 pi over 6, which is 2 pi over 3. Okay with that? So Q is at 2 pi over 3. Q is at 2 pi over 3. P is at 1 pi over 3. P is at 1 pi over 3. You need to know that. And if you're good with that, that's only, well, O is 0, 0, right? O is 0, 0. So that's 2 pi over 3. That's, I'm sorry, 1/3, 2/3, okay? Now, the figure shows radius 4. Oh, damn it. So pi over 3, pi over 3. Look at A. 4 cosine pi over 3, 4 sine pi over 3. Pi over 3 is P. Good enough? Pi over 3 is where P is. That's not what they're asking for. They're asking for Q. So A is P. Again, I think it's just as important for you guys to know which one's wrong as which one's right. And if it's wrong, why it's wrong. A is point P. A is point P. Oh, I don't want to draw again. If I go 5 pi over 6, I'll go 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. I'm going to end up over here. B is nothing on this particular point. B is not a single point. B is over here. Z, I don't know, something. B is not on this triangle. C, 2 pi over 3. 1, 6, 2, 6, 3, 6, 4, 6. Now this is where you get tricky. Y'all okay? And then D goes 2 pi over 3. Except the x value is negative. This is a trick. So if this was a test question for you guys, I hope nobody would choose A, and I hope nobody would choose B, because there's no way that A could get there because that's point P. And there's no way B can be there because that's not even a point on this triangle. And that's this class. 4 answers are multiple choice, and 2 of them are always wrong, no doubt. And then the other 2 are sometimes 50-50. And that's kind of where we're at on this one. Because I'm going to guess some of you might say C, and some of you might say D. I don't know. I don't know. Does anybody know the answer before I tell you the answer? Which one do you think it is? Do you think it's C, or do you think it's D? Anybody want to speak up? No? I'm scared? C. It's C. It's C. Because the 2 pi over 3 is going to get you to quadrant 2. You with me on that? The 2 pi over 3 is going to get you to quadrant 2. And if I get to quadrant 2, they're asking for that point. I don't think they want D. I don't know now. Dang it. Grayson, what do you think? I got to cheat. I don't want to tell you guys wrong. I don't do that very often. Where am I at? What is this? Notes. Close, 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 close. Backspace. Sorry. Dang it. Go ahead. Oh, I don't know. 805. This is what? Notes. 3.3 notes. 3.3 notes. Back up one more. Back up one more. Notes. Y'all have a guess? Y'all say, I think it's C. I think it's D. You think it's C? You think C? You think D? I don't know. What am I on? 3.3 notes. Key. It's C. It's C. As the figure, right, hold on, is this it? Yeah, example number 1. That's what we just did, right? Example number 1. As the figure illustrates, it takes 3 inscribed equilateral triangles. I don't know. Because the 2/3 is going to get you to quadrant 2. And if you do a negative, you're kind of putting it back over into quadrant 1. You're kind of going opposite of the 2/3. Yeah. You okay? Hit me. Yeah. To verify that thought, right? To verify that thought, what did we say? X is r cosine theta, and r is the radius, and r is always positive. The hypotenuse is always positive. It's never negative in unit 3. If we did unit 4, it might be negative. Those of you guys that have done physics and done some other stuff, polar coordinates. Anyway, X can be negative or positive or negative. Y can be positive or negative. R is positive. Well, to get this point, it's r cosine theta. So R has to be positive. Should have went with my gut. Pretty sure I was right. Everybody okay with that now? Again, I don't think it's important for you to know that C is right. I hope you know why the other ones are wrong. Because on the test, I'm not going to give you this question on the test. You're not going to get this question. You're going to get a triangle somewhere else with some other point. And so knowing which one's right is just as important as knowing why the other ones are wrong. Okay? Ooh, look at this one. Ooh. The figure above shows the circle of a radius r with a line y equals negative x. You should know y equals negative x has a slope of -1, over 1, down 1, over 1, down 1, over 1, down 1, with a y-intercept of 0. That's like the easiest line in the world to draw, except it's the hardest because we're not used to seeing y equals x. We're used to seeing y equals 1/2 x plus 6. Y equals x is 0, up 1, over 1, up 1, over 1. This is 0, down 1, over 1, down 1, over 1. So now we know it's what? An equilateral triangle or an isosceles triangle. How about that? Not an equilateral, isosceles. Intersects at R, O, and P. P is 6. P is 6. Uh-oh. Dadgummit, I always hit that button. I'm over here. 6 root 2 negative 6 root 2. Well, I hope that P is a positive point and a negative point. I hope X is positive and I hope Y is negative. I hope X is positive and I hope Y is negative. Because if it's not, I'm not getting a P. I'm not. They just want to know what the point of R is. Ooh, R. Hold on. Careful. R is right here. Not big R. See, that says little r. I want the little r. Big R is negative 6 root 2, positive 6 root 2. I think it's no negative. Negative root 6. I'm sorry, negative 6 root 2, positive 6 root 2 for here. But they want that point. I got to use the Pythagorean theorem to figure out what the hypotenuse is, which I think it told me already, didn't it? Oh, no, it didn't tell me. But the radius has to be 6. If this is 6 root 2 and this is 6 root 2, hit me. 12. I was getting ready to have to double it because I got 2 of those. Use Pythagorean theorem. Nothing you don't know. If you square 6 root 2, you get 36 to 72. And you get 72. And if you add 72 and 72, you get 144. And the square root of 144 is 12. Use Pythagorean theorem. And if the radius is 12, then this point right here has to be 12, 0. Has to be 12, 0. Because it's nothing more than the radius. That is the radius. Same distance as that. Same distance as that. So this was 6 root 2, and this was negative 6 root 2. And so just use Pythagorean theorem to figure out what the radius is. And once you figure out what the radius is, now you can figure out what r is. And so you needed to square 6 root 2 plus b squared is equal to c squared, or x squared plus y squared is equal to z squared, or I don't care how you have Pythagorean theorem. And if I square that, it's 6 times 2, that's 36 times 2, which is 72. And this is going to be 72, and I lost my thing. And if that's 72 and that's 72, that's 144, and the square root of 144 is 12. Be careful, they want a little r. Hit me. And if you know the 45, 45 right triangle, to get the hypotenuse, all you need to do is multiply it by the square root of 2. If you know 45, 45, 90, all you have to do is multiply the short side by square root of 2. And if you take 6 times the square root of 2 times the square root of 2, you'll get the square root of 2 times the square root of 2, which is 2, and then 2 times 6 is 12. You can speed up that process. Beautiful. Okay. This is a quiz that you guys will get at some point. I will give you a quiz just like example number 3 with 1, 2, 3, 4, 5, 6, 7, 8, probably 10. And ask you to find those values. And you should know them. You should know them. And you should know them almost as fast as you know addition and subtraction and multiplication. Almost. It will take you a little while. You may have to do some drawing. When I first learned this, 1, 2, 3, 4, 5, 6, 7, 8, I had 8 circles. I had 8 circles and I drew 8 angles. Don't have to. Cosine 0. Uh-oh. Can't do it without a pencil. Let me change colors. Black. Cosine 0. 0 is right here. How far does cosine have to go out? 1. You should know that cosine of 0 is 1. Learn that day one when we started talking about a dog and a duck. The duck's on the water. Cosine had to go 1 unit out there to get him. Pi over 2. That's a nice one. You should know that pi over 2 is the one that's straight up in the air. Straight up in the air. You got to know that that's where pi over 2 is. So that's the first thing you got to know is where pi over 2 is. Because if you don't know that, hard for me to tell me what cosine of that is. And the cosine, duck falls right in the boat. Falls right into the boat. 0. I'm skipping. I'm doing A, C, G. Oh, who cares? Cosine of pi. There's pi. Dog had to turn around. -1. And again, at some point, you just got to know these things. And I'm going to give you some things to practice. And you're going to have some homework to practice. And if you got to draw it, draw it. I would rather you know it, but if you got to draw it, draw it. And I think it helps to draw it because if I'm over here, something better be negative. Something better be 0. If I'm talking about sine, it's 0. Duck's on the water. I'm straight over there. Duck's on the water. 3 pi over 2. 1 pi over 2. 2 pi over 2. 3 pi over 2. 3 pi over 2. So the duck, that's super duck, right? He's right underneath the water. But all I care about is the cosine. I don't care about the duck. I care about the dog. And I shoot the duck right underneath the water. It floated up and cosine didn't have to go anywhere. Good? And now we got the sine of those same angles. Sine of those same angles. 0, pi over 2, pi, 3 pi over 2. Yours is not going to be that easy because I'm going to give you some fourths and I'm going to give you some thirds and I'm going to give you some sixths. And some of them are going to be positive and some of them are going to be negative. But y'all can see, I can ask, watch, look, where'd that unit circle go? Look. Where'd it go? Where'd it go? That was over here, wasn't it? Just kind of gives you an idea of how many questions I could possibly ask. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and I guess I could go back to 17. 17 different angles I can ask you about. Actually, infinity, because I can keep going around. Yay? Or 34, because I can go negative. Possible angles I could ask you. Any one of those, any one of those, any one of those. But they're all going to be a 0 or a 1 or a square root of 2 over 2 or a square root of 1 over 2 or a square root of 3 over 2. You just got to know where it is. Good? I hope it's a somewhat easy little quiz that you're going to get. That unit circle, you just got to know it. You got to know it. Oh, I don't go there, but here, done. Sorry. Let's finish this one. Where am I at? Oh, here. So sine of 0, duck was on the water. Duck was on the water. Pi over 2, duck is straight up in the air. Pi, duck is on the water. And then 3 pi over 2, super duck. He's right underneath me. If you have a tough time with the unit circle, please know these. Because if you don't know these, you can't do 3-5 or 3-6 or 3-7, or you won't be able to do any of them if you don't know those specific ones. Yay? Any questions about those? Those are like I mean, those are like the parent. Ooh, I wonder where we're going to get that from, huh? Parent points. A large portion of this course requires that we find numerical values. See, he's saying the same thing that I already taught you. Pi over 6 and pi over 4. So here's where he's talking about the 1/4 and the 1/6, and here he's proving all this stuff. He's proven all this stuff that I've already showed you and still kind of proved to you somewhat with the 30, 60, 90, and 45, 45, 90. I don't think any of this is important. Two important notes. Notice we found the values of x with the Pythagorean theorem. There's the 1/2. There's the 5 pi over 6. The Pythagorean theorem plays an important role in the trigonometry. We'll see additional ways. Here's the square root of 3 over 2. Here we go. I'm going to come down to example number 4. Sorry. Kind of skipped a bunch of stuff. But again, I need both. I need both. I can pull it up just a little bit. P, Q, R, and S. And it gets a little confusing because you got a whole bunch of lines going on. That's a little confusing, a little overwhelming to look at, but I noticed that P has a square root of 3 over 2 and 1/2. So I bet this has a square root of 3 over 2 and 1/2, and I bet that has a square root of 3 and 2 and 1/2, and I bet that has a square root of 3 and 2 and 1/2. Just some of them are positive and some of them are negative. Yay, good, because they're nothing more than reflections. This is reflected over here. This is reflected down here. This is reflected over here. This point is reflected through the origin. So this point will be negative square root of 3 over 2, negative 1/2. Because this is the short side. This is the long side. Long, short. Short has to be the 1/2. Long has to be the square root of 3 over 2. Long, short. And I'll cheat when I do these, guys. I'll draw it like this. I'll cheat. That's not really 1/6, but that really emphasizes this has to be the short and that has to be the long. So this has to be the 1/2 and that has to be the square root of 3 over 2. Well, if it's 45, it doesn't matter. They're the same distance. So you should be able to fill out the rest of this little points by P, Q, and R and S. Oh, the angle. They want the angle too. So that was what? 1/6, 1/6, 2/6, 3/6, 4/6. This is 5/6. 5 pi over 6. And count them if you have to. Just count. Just don't skip things. 1/6, 2/6, 3, 4, 5, 6, 7. 8, 9, 10, 11. Yes, you will start seeing a pattern. I hope. 1, 5, 7, 11. Amazing. And this is going to be the square root of 3 over, or square root of 3 over 2, 1/2. And this is going to be the square root of 3 over 2, 1/2. And this is going to be the square root of 3 over 2, 1/2. Just some of them are negative. What do we decide? R both negative. R both are negative. Q, X is negative. S, Y is negative. These are questions that will be on your test. I mean, there are students that will have a really tough time with this. I don't get it, but I hope it's none of you cats. It's not, because you guys are freaking smart. Yippee, yippee, yo. One more, and then we'll be done. I'll call it a day. Well, here's where we're talking all about the 45s. Here's where we're talking about the 45s. So we got a bunch of stuff over here that proves all this stuff that we've kind of already done. 1/4, 2/4, 3/4. 4/4, 5/4. 6/4, 7/4. Check your main one. You know that that's 1 pi. You know this is 2 pi. If you don't end up at 2 pi, you've done something wrong. 1/4, 2/4, 3/4, 4/4, 5. Why don't I just count by odds and skip okay, good. 1, 3, 5, 7. Beautiful. Speed up the process. I guarantee it, every one of these are going to be square root of 2 over 2. Because any force is going to be a square root of 2 over 2. It's just your job to do the positives and the negatives. It depends on what quadrant we're in. Q's in quadrant 2. So X has to be negative. Y is positive. R is in quadrant 3. They're both negative down there. They're both negative down there. S. X is positive, Y is negative. I'm getting some bored looks. That's good. I want you to be bored with this. Not really, but anything, I always assume that this is really, really easy, and I think it is, but I have to remember that I have a degree in mathematics, and I've been doing this for 28 years, and it's kind of the first time you guys have seen it. I have to remember that sometimes. Oh, now he's at the thirds, which is the same thing as the sixth. Same thing as the sixth, it just reduces. Because here's 1 6 and 2 6, 3 6, 4 6, 4 6, 4 6, 5 6, 6 6, 7 6, 8 6, 9 6, 10 6. You guys are probably better by counting by the thirds than I am. I just have to count by 6 because I know that I'm just not smart enough. I forget which one's to skip and which one's not to. And again, every one of these points are going to be 1/2 square root of 3 over 2. You just got to figure out what's positive or negative. And those are the, how many points did we decide it was? 17? There's 4 of them there, there's 4 of them there, and there's 4 of them there, and then there's the 4 zeros and 1s. And they didn't come all the way around. They didn't touch it back to the 2 pi because 2 pi and 0 are the same. 2 pi and 0 are the same. So they didn't say 17, they just said 16. That's why you got 4 here, and 4 here. Another 4, I think. 4, 4, 4, 4. 30s, 60s, 90s, and the 45s. Good enough? Oh, there it is. The Holy Grail. That's the blank sheet that I gave you guys, gosh, last Wednesday, right? That I didn't care if you filled it out or not. I don't care if you fill it out or not. The blank sheet I gave you had a spot to put degrees also. I for sure don't care if you do the degrees. Every one of those points is fair game on a test without a calculator. Every point is fair game on a test. And you got to know them. Because it might be a multi-step question where you got to know that to go on to something else. Good enough with all I'm saying? And so memorize it. I don't care. There's tricks that you can memorize, all kinds of things. I just think knowing it is better than knowing them little tricks. Little tricks are fine, but if you mess up the little trick, you're going to mess up 17 points. If you know it, you're not going to mess them up. You know that this is the short and that's the long. You know that those are the same. And this is the short and that's the long. And it has to be a mirror image of one of those. There's a blank one you can fill out. These are the ones you're going to see on your test. How am I doing? Where am I at? 828. That's pretty good. Is that the last? So I'm going to give you, listen to me, okay? Give you, tonight I'm just going to give you one website. At some point, I'll give you another website. Another website just pops these things up. And you just tell me what it is. Tell me what the value is, right? For practice. It's practice. I don't care. I don't care if you go to the website or not, but man, it's just great practice. You click and it says wrong or yay. Good enough? These, you just got to know these guys. You got to know them. And the slight curveball to all this is all these are sines and cosines. We got to know sine, cosine, tangent, secant, cosecant, and cotangent. So now we've really exponentiated how much you need to know. But what's nice is if you know sine and cosine, you do know them all. Because they're just flips of some of those. And tangent's nothing more than sine over cosine. So if you know the sines and cosines, you can find any of the others. Yay? This is how I would do this problem. Letter E. I'm going to go right to E. I'm not going to do them all. I'd go to E. This is what I would do. Still to this day, 4/3. I'm drawing this, and I'm going 4/3. Now I'm going to go what? 4/3 is the same thing as 8/6. This is just me. You guys are, some of you guys, no, you guys are smarter than me on this part. 1 6 2 6 3 6 4 6 5 6 6 6 7 6 8 6. 8 6. That's it. And cosine. And cosine has to be what? The short side or the long side? Short. It's short because cosine is the x value. And so it has to be a 1/2, except going that way. -1/2. Hopefully you can do it without the circle. Hopefully you can do it without the lines and all that. But if you want to be sure, you got plenty of time on a test. Draw it. Know for a fact it's negative because I end up on that side of the axis. It has to be negative. Yes, no, maybe? Cosine of pi. Hopefully that was like starting to get real easy because that's just over there. That's -1. Those help my dog and duck more than any of them, I think, is the 45s, 35s, or 45s. Not 45s, sorry, the 90s. Axes. And I don't want to see on the test somebody going, I don't really want it. If an administrator comes in and sees somebody going, like, we're in trouble. Well, don't do that. But if it helps you remember, at least visualize it. I got another teacher go, you really do that in class? I said, yeah, we're from Arkansas. It's okay. We're in northeast Arkansas, where I grew up. Everybody hunted. That was the last thing. Everybody okay? Y'all good? Okay, so here's what I'm going to give you guys for homework. Finish. Go ahead and do 3-2. What was it? 3-2-2. Go ahead and finish that worksheet. Just go ahead and finish that worksheet. And then I'm going to send you a website. Okay? And the website is going to be linked on Google Classroom. Looks just like, no, doesn't look like that one. It looks like this one minus those points over there. Okay with that? And it's going to ask you, it's just going to pop up, and it's got points. How many points there are all the way around it. That's point T. It's going to ask you for the, no, I apologize, I forget. I don't know what all it does. Anyway, it asks you a lot of points. And if you get it right, you get it right. And if you get it wrong, you get it wrong. I don't care. And when you get done filling that thing out, screenshot it. Screenshot it, put it on a doc, put it on somewhere, and that's what I want as your homework. I want the uploaded, finished 3-2. Uploaded, finished 3-2, those worksheets. Are the rest of them all multiple choice? Who finished it? Well, the rest of them all multiple choice, or the rest of them work? If they're multiple choice, I really don't care if you upload them or not. The multiple choice pages, I don't care if you upload those or not. I'll be honest with you. It's a whole page for 2 circles. And I don't know if you did it or not. Good enough? So I really don't care about that part. It's the work. So finish 3-2B and then screenshot the website I'm going to take you on how long it took you to finish that. And I don't care how long it took you. And if you got your blank one right here, and I don't care. I just want to know that you filled it out. So that at some point I can say, at some point you knew this. Good? Y'all okay? Happy, happy? And we got it due on Monday. Due on Monday. So a couple of you knuckleheads didn't finish 3.2 or didn't upload 3.2. Make sure you upload 3.2.1. If you upload all the 3.2 on that, that's okay too. I just need all the 3.2 somewhere, either 3.2.1, 3.2.2, or all three, or all whatever. Get it all on there, and then a screenshot of that website I'm going to give you. And then on Monday, we're kind of a day ahead of all the other classes. Monday, I'm going to give you 3.3 and a Delta math. And we're just going to call Monday a work day. That way I don't have to teach and you guys can somewhat learn. Yay? We'll kind of work it that way. We'll be a little off from the other classes, but that's whatever. We don't care. We always go to a different beat anyway. All right. Beautiful, beautiful, beautiful. Anybody?